welcome to Data Management, Grade 12, MDM4U, Lesson 1.5, Independent and Dependent Events. So today's learning goals, you're learning to describe and determine how the probability of one event occurring can affect the probability of another event occurring, and solve probability problems involving multiple events. So let's give you some background. When multiple events occur in a probability experiment, these events are called compound events. Sometimes the probability of one event depends on whether another event occurs, and sometimes it does not. When one event has no effect on the probability of another, the events are called independent events. Obviously, you can guess the opposite of that is that when one event does have an effect on the probability of another, it's called dependent, but we'll come to that in a minute. So let's take a look at this first example. Olivia has 4 highlighter pens in her pencil case. 2 yellow, 1 green and 1 orange. She reaches into her pencil case and randomly chooses a highlighter. After she uses it, she immediately replaces it in the case so it can be used again. What is the probability that she will choose 2 yellow highlighters in a row? So now the key words with this are she replaces it. So therefore it doesn't affect the probability next time that she chooses one. But let's see. So her choices are, let's do this, yellow, green, and orange. Okay, she has 2 yellow, 1 green, and 1 orange. For now, we just know that when she puts her hand in a case, she's going to come out with a yellow one, a green one, or an orange one, right? And then she's used the highlighter, puts it back in, and then she goes in for another highlighter for the second one. Well, the second time she goes in, she can pick out a yellow, a green, or an orange. And again. So now we're going to build this little tree. And try and fill in the values here. Okay, so what is the probability that she will choose 2 yellow highlighters in a row? So probability of a yellow and a yellow. Well, we need to be looking at this here, yellow and yellow. So first of all, what is the probability of her choosing a yellow in the first place? Well, let's think about it. We have 2 yellow, 1 green and 1 orange. So we have 4 possibilities. So a sample space is 4. And she could choose a yellow for 2 of those outcomes. The green is only 1 and the orange is only 1. And this is how we label it. We label our probabilities on top of the lines that lead to our outcomes. And then for the second go, we can repeat those because she has replaced the highlighter back in the bag. So the probability of getting a yellow and a yellow is 2/4. And what we do is we multiply, right? So, and I want you to associate with multiply. So we multiply that to 2/4, which is simply a half times half, which is 1/4, or 0.25 or a 25% chance. Okay. What about a yellow highlighter followed by a blue highlighter? Well, a blue highlighter. Well, there are no blue highlighters. I think that's a mistake. I think that was meant to say green. Let's change that up to green. Okay, so probability of a yellow and a blue. Sorry, a green. Again, we multiply. So this and means multiply. So we have 2/4, and then the green now is 1/4. So together that gives me 2/16 or 1/8. Okay. So the multiplicative principle, which is what we've just done, the fundamental counting principle for independent events. They're independent. So the second pull of the highlighter was not influenced by the first one. So it's just simply the probability of A and B is probability of A times the probability of B. So I want you to just associate the word and with multiply. So let's verify our answers to number 1 using the multiplicative principle. Well, we just did that. Really, we just did that above. Okay. So example 2. What is the probability of rolling a standard die and drawing a card from a standard deck and getting a 4 and an ace? So we're going to roll a dice and then draw a card from a deck. Hopefully you would agree that these are independent events because they have no influence on each other. So let's see. Let's talk about event A being getting a 4 from the dice, or from a die, and from event B getting an ace from a standard deck, which is the 52 cards. Okay, so the probability therefore of getting A and B is the probability of A multiplied to the probability of B, which is simply probability of getting a number 4 when we roll a dice is 1 in 6. Probability of choosing an ace from a deck of cards, well, we have 4 aces out of 52. And we can reduce that a little bit. And that will give us the answer 1 in 78, or 0.01, so 1%. Okay. Now let's look at, well, hopefully that explains it clearly enough, right? There's no way that rolling a dice and pulling a card from a deck of cards have an influence on each other. So let's have a look at when one event does have an effect on the probability of another. This time the events are called dependent events. And the formula is a little bit different then. So let's take a look at the formula first and then we'll explain what happens. So the probability of 2 dependent events, A and B, occurring where the probability of B depends on the probability that A occurs is this. So the probability of both A and B is the probability of event A happening times the probability of event B happening given A has happened. So let's write that out. So B line A, or B slash A, is basically means the probability of B given A happened. Okay, B given A. So let's take a look at this example. Study of a telemarketing company showed that of 2,000 calls placed, the experimental probability of a call receiver staying on the line for at least a minute was 16%. So let's call that event A, of staying on the line for at least a minute. And 16% as a decimal, 0.16. Do remember to always convert your percentages into decimals. The conditional probability, so this is your key word here, conditional. It's conditional upon a call resulting in a sale. The conditional probability of a call resulting in a sale, given that the receiver stayed on the line for at least a minute, which we already have back there, was 10%. So then we can write probability of B, given that A happened, is 0.10. No sales were made if the receiver did not stay on the line for at least a minute. Okay, so how many sales were made? So what is the probability, therefore, of A and B? In other words, the caller stayed on the line for at least a minute and a sale was made. Okay, then we need to look at this. So the probability that they stayed on the line for at least a minute was 0.16. And, which is multiply, the probability that a sale was made, given that they stayed on the line, was 0.10. And that's it, 0.016, or approximately 2%. Okay. So interestingly, let's have a look. They had 200 calls placed. So what would their sales look like? Just how for fun. So the sales therefore would be the 0.016 times the 2,000 which is 32 sales made. And that's about industry standard, I believe. Okay. Let's have a look at another one. The game of roulette uses a wheel with 38 spaces on it that include 18 red, 18 black, and 2 green. What is the probability of the wheel landing on a black number twice in a row? Okay. So let's have a look at this. So we'll use the letter B. So we'll let B be the event that it lands on black. And let's take a look. So the probability of a B followed by a B will be what? Well, the first event, there are 18 blacks out of 38 spaces. And the second event of it landing on a black again, well, it's the same wheel. It hasn't changed. So it'd still be 18 out of 38. Which is 324 out of 1,444, which is approximately 0.224. So about 22%. What's the probability of the wheel landing on a black number than a red number? Then that would be the same. Right? Because there are 18 red spaces too. So it would still be 0.224. And that's it. So this one is an example of independent. So even though we're looking at the same thing, it's kind of like with replacement. We don't lose the black spot once you've landed on it. It's not eliminated from play, right? So things where you have games where things are eliminated from play, those will be dependent events. Things like a roulette wheel where it's the same chance every time that you play, they are independent events. Okay, that's it for today. Good luck with your homework. See you.